welcome back to my channel. This integral, let's see, we have limit of n tends to infinity. Here we have n square into this term. Now when n tends to infinity, this n square become what? This also become infinity. Now when n tends to infinity, 1 by n, this become what? Let's see. When n tends to infinity, limit of 1 by n, okay. When n become very large, therefore this become 0, okay. This become 0, means what? Integral a to a f of x dx equals to 0. Why? Because if you have upper limit is same as lower limit, then that integral f of x dx becomes 0. Similarly, we have 0 over here we have, and then when n tends to infinity, this term become also 0. Therefore, whole this integration become 0. Otherwise, you can say limit is from 0 to 0 when n tends to infinity. Therefore, this whole term become 0. Here we have infinity. So when n tends to infinity, it is of the form infinity into 0. Okay. So this becomes infinity into 0. Now if I want to apply L'Hospital rule, what it should be? It should be either 0 by 0, or it should be either plus minus infinity by plus minus infinity, okay, for L'Hospital rule. Now this can be written as limit of n tends to infinity, integral 0 to 1 by n x raised to 2023 x plus 1 upon here is dx upon this. I can write 1 by n square, okay. This is same as this. Why I am doing this? Because I want to use LH rule, okay, L'Hospital rule. Over here, this denominator is what? When n tends to infinity, it is of the form what? It is of the form 0 by 0, okay. Here denominator is become 0 when n tends to infinity. Here numerator also when n tends to infinity, it becomes 0. So we have 0 by 0. Therefore, we can apply L'Hospital rule, LH rule. Now for LH rule, for L'Hospital rule, okay, we need to differentiation of this is with respect to n is quite easy over here in denominator. What about this? Okay, let's see this differently. Now d by, what is d by dn of this? Integral 0 to 1 by n x raised to 2023 x plus 1 dx, okay. Now we need to differentiate with respect to n this integral, okay, by applying what? Fundamental theorem of calculus. So by fundamental theorem of calculus, let's apply over here. By fundamental theorem of calculus, what we have to do is you have to consider x equals to 1 by n over here, okay. Therefore this is become what? So 1 by n raised to 2023 x is what? 1 by n, and then we need to differentiate d by dn of this 1 by n, okay. This is what? This is by fundamental theorem of calculus, second fundamental theorem of calculus. You can see one of my videos, okay. So this is equals to 1 by n. Here we have plus 1, okay. Here we have plus 1, okay. So this equals to 1 by n. Here 2023 n plus 1, and then what is this, okay. So this is same as minus 1 by n square. Now differentiation of this with respect to n is this, okay. Besides from these questions, let's take some example for fundamental theorem of calculus how to solve, okay. Now here let's consider this example. Here we have some example, okay. Example of fundamental theorem of calculus. Now let's consider this example, okay. Why I am giving example? Because you will have clear idea about what is application of fundamental theorem of calculus, okay. Now since this d by dx of find d by dx differentiation of this, okay. Now what we have to do is we have to substitute, put x equals to what? T, okay, in this. So this become what? Sine cube x square upon cube root of, here become what? X raised to 5 plus 1 into, okay, into d by dx of x is what? 1, okay. So we don't have to write anything. So therefore, this is the answer. Now let's substitute this, okay. Now let's substitute this over here, okay. What we have is equals to limit of n tends to infinity. D by dn of numerator is what? We have this, okay. So I will substitute this equals to over here. This is 1 by n 2023 n plus 1 minus 1 by n square upon this with respect to n, okay. So what we'll have, this is same as minus, so minus 2 by n cubed, we have this, okay. Limit of, here we have limit of n tends to infinity. Now let's separate this and this, okay. So 1 by n raised to 2023 upon n, 2023 upon n into, I can say this raised to 1, okay. So I can say 1 by n. Okay, now this I will keep as it is, minus 1 by n square upon, here minus 2 upon n cube, okay. Now this, here minus, this minus and this minus gets cancelled. N into n square is n cube, this and then this n cube gets cancelled. So what we have, limit of n tends to infinity, 1 by n raised to 2023 upon n into, we have 1 by 2, okay. This 2 is over here. So is equals to limit of n tends to infinity. This can be written as 1 by n raised to 1 by n, and this 2023 I can write like this, 2023, okay. So this half I am writing over here, okay. So I am bringing outside. Now we have some formulas over here. Remember, limit of x raised to x when x tends to 0 plus is equals to what? 1. Okay, these are some formulas you have to remember. Similarly, number 2, limit of sine of x upon x where x tends to 0 is equals to what? 1. 3, limit of x tends to infinity, x plus 1 by x raised to x equals to e. Okay, these are some formulas you have to remember, okay. Now look at here, when n tends to infinity, when the value of n keep on increasing, therefore whole this become what? Whole this become, therefore by applying this formula, so this is same as half we already have into this become what? 1 raised to 2023. So 1 raised to anything is what? 1, therefore we have half. So this is the required answer for this.